Hello students and good morning. So now I am doing class for class 11 science. The topic is the same topic that we were doing in the last online class, that is trigonometrical ratios of compound angles. So today is the continuation class. So we'll do the same exercise 4, 5 marks section from page number 139 from the book Mathematics for class 11 by Sailendra. So let's do this question number 1 from 5 marks section. So let us prove that tan of a plus b minus tan of a minus b is equal to sin 2b divided by cos square b minus sin square e. So let's do this question now. So now here let us prove LHS is equal to RHS. So LHS is equal to, so here LHS is equal to, this is tan of a plus b minus tan of a minus b. Okay, so you have to prove this LHS is equal to RHS, and RHS is in terms of sin 2b, cos b and sin a. So let us convert this tan into sin by cos. So which is equal to sin of a plus b divided by cos of a plus b minus, similarly, what is tan of a minus b? It is sin by cos. So this is sin of a minus b divided by cos of a minus b. Is that clear? So what's the LCM? Let us take the LCM out here. This is cos of a plus b into this is cos of a minus b, right? So this is the LCM. So cos of a plus b will be cancelled. We get cos of a minus b. Now it is multiplied by sin of a plus b into cos of a minus b. Then next minus. Now cos of a minus b will be cancelled. We will have cos of a plus b. So it should be multiplied by sin of a minus b. That is cos of a plus b into sin of a minus b. Is that clear? So we have got this expression. So in the numerator you can use the formula sin a cos b minus cos a sin b, and in the denominator you can use the formula of cos of a plus b into cos of a minus b. So is equal to, what is the formula in the numerator? It is sin a cos b minus cos a sin b. Here a plus b is a and a minus b is b. Okay, so it is sin of a minus b formula. Sin, what is a here? A plus b minus b. What is minus b? Minus within bracket a minus b, and here b is a minus b. So because of this minus sign changes, minus a minus plus b. It is plus b, this whole divided by, in the denominator, what is the formula for cos of a plus b into cos of a minus b? It is cos square b minus sin square a. It is cos square b minus sin square e. So which is equal to, now here a gets cancelled, you can cancel it. So it is sin, this is b plus b is 2b divided by, so cos of a plus b into cos of a minus b, what is this formula? Cos square b minus sin square e, right? So divided by cos square b minus sin square e. So it is proved. So I think you have understood it. Okay, so there is formula for cos of a plus b into cos of a minus b as, this is cos square a minus sin square b. This is one of the formula. Other formula may be, it is cos square b minus sin square a, right? So instead of cos square a, if you write 1 minus sin square a, and instead of sin square b, if you write 1 minus cos square b, and if you simplify it, you will get cos square b minus sin square a. So the formula for cos of a plus b into cos of a minus b is cos square b minus sin square a. So we have proved the required result. So I think you have understood it, so you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 2. The question is, if tan beta is equal to n sin alpha cos alpha divided by 1 minus n sin square alpha, then prove that tan of alpha minus beta is equal to 1 minus n into tan alpha. So from given, you have to prove LHS is equal to RHS. So in the given part, the value for tan beta is given in terms of sin alpha and cos alpha. Okay. So how can you prove this LHS is equal to RHS? So on the left hand side, there is tan of alpha minus beta. And in this case, you can use the formula of tan of a minus b. So what is tan of alpha minus beta? Tan alpha minus tan beta divided by 1 plus tan alpha tan beta. Now instead of tan beta, you can write down the given here, given value for tan beta. And what will you do with this tan alpha? You have to write, instead of tan alpha, sin alpha by cos alpha. Then you have to simplify it. You will get the required result, that is LHS is equal to RHS. Okay. So let us write down here LHS. So here LHS is equal to, this is tan of alpha minus beta, which is equal to, what is the formula? This is tan of a minus b, tan alpha minus tan beta divided by 1 plus tan alpha tan beta. Is that clear? This is the formula, tan a minus tan b upon 1 plus tan a tan b. Here a is alpha and b is beta. So instead of tan alpha, what will you write? It is sin alpha by cos alpha minus, and instead of tan beta, write down the given here. What is given value for tan beta? It is n sin alpha cos alpha divided by 1 minus n sin square alpha. Is that clear? Next, 1 plus, what is tan alpha here? It is sin alpha by cos alpha. And what is tan beta? Let us put the value for tan beta. This is n sin alpha cos alpha divided by 1 minus n sin square alpha. So it is, so we have used the value for tan beta. Okay, and the value for tan alpha is sin alpha by cos alpha. That is the formula, right? So here you can cancel this cos alpha, and this cos alpha will be cancelled. Okay, so what's the LCM in the numerator? So what's the LCM in the numerator here? In the numerator, the LCM is cos alpha into 1 minus n sin square alpha. 1 minus n sin square alpha is the LCM in the numerator. Okay, so this LCM is divided by cos alpha now. So cos alpha will be cancelled. So you will have sin alpha into 1 minus n sin square alpha, 1 minus n sin square alpha. Then after that, this LCM is divided by 1 minus n sin square alpha. So 1 minus n sin square alpha will be cancelled. So it is only cos alpha. So this cos alpha should be multiplied by n sin alpha cos alpha. That is minus n, right? Minus n. Then what do we write? Sin alpha cos square alpha. Sin alpha, then it is cos square alpha. Is that clear to all of you? So we have simplified the numerator. Now let's simplify the denominator here. So what's the LCM here? The LCM is 1 minus n sine square alpha. The LCM is 1 minus n sine square alpha. Now it should be multiplied by 1. What do we get? 1 minus n sine square alpha, right? 1 minus n sine square alpha, then plus n sine square alpha. Plus this is n sine square alpha. So I think you have understood it. Okay, so we have simplified the denominator. So here you can cancel this 1 minus n sine square alpha from both the numerator as well as in the denominator. And you can cancel this n sine square alpha also. So let us simplify it further. Sine alpha into 1. This is your sine alpha minus n. This is sine cube alpha. Sine alpha is multiplied by n sine square alpha, that is minus n sine cube alpha, then minus n sine alpha, and this is your cos square alpha, whole divided by, in the denominator we have cos alpha into 1, that is your cos alpha. Is that clear? So next, which is equal to sine alpha minus, what is common out here? It is n sine alpha is common, so within bracket what do we get? It is sine square alpha minus into minus plus n sine alpha is taken common, so it is cos square alpha. This whole divided by, this is your cos alpha. And what is sine square alpha plus cos square alpha? That is your 1. That is the formula, right? So here you can write sine alpha minus n sine alpha into 1. You don't have to write it, divided by cos alpha. Is that clear? So next, in the numerator, what is common there? Sine alpha. So we have within bracket 1 minus n into sine alpha divided by cos alpha. So now what is sine alpha by cos alpha? That is your tan alpha. So it is 1 minus n into what is sine alpha by cos alpha? That is your tan alpha. So it is proved. So which is equal to right hand side, that is 1 minus n into tan alpha. So we have proved it. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 3. If m tan of within bracket theta minus 30 degree is equal to n tan of within bracket theta plus 120 degree, so that cos 2 theta is equal to m plus n upon m minus n. From given, you have to prove the value for cos 2 theta, which is equal to m plus n upon m minus n. So let us prove it now from given. Okay, so here given is m tan of within bracket theta minus 30 degree is equal to n tan of within bracket theta plus 120 degree. Okay, so now in this case, since we have to prove m plus n upon m minus n, you keep the terms containing m and n on one side and the trigonometric function on the other side. Okay, so let us take this n to the left hand side and this tan theta minus 30 degree to the right hand side. Okay, so m upon n is equal to, this is tan of theta plus 120 degree divided by tan of, this is theta minus 30 degree. Is that clear? So now you can change their sides. So m by n, take it to the right hand side, and this tan, take it to the left hand side. So you don't have to change the sign here, because if you change the sign, if it is taken to the left hand side, it becomes minus, m by n, it becomes minus sign on the right hand side. So minus minus will be cancelled, that you will get positive. So you don't have to change the sign here. Okay, So that is tan of theta plus 120 degree divided by tan of theta minus 30 degree, which is equal to, this is m upon n. So now you have to prove cos 2 theta is equal to m plus n upon m minus n. So in order to get m plus n upon m minus n, you have to use componendo and dividendo. So before you use componendo and dividendo, let us convert this tan into sine by cos. So, or now this is, in the numerator we have sine theta plus 120 degree divided by cos of theta plus 120 degree, right? And in the denominator it is sine of theta minus 30 degree divided by cos of, this is your theta minus 30 degree, right? So which is equal to, this is m upon n. So now let us simplify this left hand side. So now when this denominator goes up in the numerator, it becomes upside down. Okay, so what do we get now? Or this is sine of theta. This is sine of theta plus 120 degree. 120 degree divided by, that is cos of theta plus 120 degree. Cos of theta plus 120 degree into, when this denominator goes up in the numerator, it becomes upside down. You know that, isn't it? So cos of theta minus 30 degree, it goes up in the numerator. Cos theta minus 30 degree goes up in the numerator, and there will be sine of theta minus 30 degree, which is equal to, what is there on the right hand side? It is m upon n. It is m divided by n. So I think you have understood it. Okay, now we have to use componendo and dividendo. So you know componendo and dividendo, isn't it? So by componendo and dividendo, by componendo and dividendo, comma, we have, by componendo and dividendo, comma, we have. So you can use componendo and dividendo on both the sides, and you write down positive sign in the numerator, because we have to prove positive sign in the numerator. Okay, so what is componendo and dividendo here? So on the left hand side you have to write down numerator plus denominator. So it is sine theta plus 120 degree cos theta minus 30 degree, that is your numerator, plus, which is the denominator, cos theta plus 120 degree into sine theta minus 30 degree. Okay, this whole divided by, in the denominator, numerator, that is sine theta plus 120 degree cos theta minus 30 degree, then minus, what do we write now? Minus, you have to write down the denominator. So what is the denominator in this case? It is cos theta plus 120 degree into sine theta minus 30 degree. That is, on the left hand side, it is numerator plus denominator divided by numerator minus denominator. Similarly, what is there on the right hand side? So on the right hand side you have to write m plus n divided by m minus n. So this is your componendo and dividendo. Is that clear? So next, what will you do in the next step? Now here, in this case, in the numerator, if you take theta plus 120 degree as A and theta minus 30 degree as B, so this will be sine A cos B plus cos A sine B. So this is sine of A plus B, right? In the denominator also, if you take theta plus 120 degree as A and theta minus 30 degree as B, this will be sine A cos B minus cos A sine B, which is equal to sine of A minus B. Okay, so let us write in the numerator sine of A plus B. What is A plus B? theta plus 120 degrees is A plus B. Plus what is B? Theta minus 30 degree. Divided by, in the denominator, sine of A minus B. What is A? Theta plus 120 degree. What is minus B? Minus theta minus into minus plus 30 degree. Which is equal to, on the right hand side, we have m plus n upon m minus n. So I think you have understood it. Okay. So, or now this is sine of, this is 120 minus 30. This is 90 degree plus theta is twice theta, divided by, here theta gets cancels. So this is sine of 120 plus 30 is 150 degree, is equal to m plus n upon m minus n. So I think you have understood it. So let us get the value for sine 150 degree. Okay. So sine 150 degree. So you know how to get the value for sine 150 degree, which is equal to sine, this will be 180 minus 30 degree. So 180 minus 30 degree lies in the second quadrant. In the second quadrant, sine is always positive. Okay. And 180 is 90 multiplied by 2. That is even multiple of 90. So sine remains as it is. So which is equal to sine 30 degree. So it is half. So sine 150 degree is half. Or, now what is sine 90 plus theta? 90 plus theta lies in the second quadrant. And in the second quadrant, sine is always positive. And since 90 degree is 90 multiplied by 1, that is odd multiple of 90. So if it is odd multiple of 90, sine changes to cos. So it is cos 2 theta divided by, what is the value for sine 150? It is half, which is equal to m plus n upon m minus n. So is that clear? So now you can simplify. So when this half goes up in the numerator, it becomes upside down. So 2 is in the numerator, that is 2 cos 2 theta divided by 1. So dividing by 1, if it is 1 there, you don't have to write it. So it is 2 cos theta is equal to 2 cos 2 theta. 2 cos 2 theta is equal to, this is m plus n divided by m minus n. So it is done. So we have proved that. So it is 2 cos 2 theta, right? This should be 2 cos 2 theta. That is wrong. So I have written the wrong question out there. So it should be, so that 2 cos 2 theta is equal to m plus n divided by m minus n. This is the correct question. Okay. I have made mistake out there. Okay. This should be 2 cos 2 theta is equal to m plus n divided by m minus n. Is that clear? So we have proved that 2 cos 2 theta, from here, when this half goes up in the numerator, it becomes 2 upon 1. So it is 2 cos 2 theta divided by 1. If it is 1 in the denominator, you don't have to write it. Okay. So it is 2 cos 2 theta is equal to m plus n upon m minus n. So it is proved. Okay. The correct question is 2 cos 2 theta is equal to m plus n divided by m minus n. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next problem, that is question number 4. The question is, if cos of beta minus gamma plus cos of gamma minus alpha plus cos of alpha minus beta is equal to minus 3 by 2. So this is given. You have to show that cos alpha plus cos beta plus cos gamma is equal to 0 and sin alpha plus sin beta plus sin gamma is equal to 0. You have to prove these two results. Hence, you have to deduce that, or you have to prove that cos of beta minus gamma is equal to cos of gamma minus alpha is equal to cos of alpha minus beta is equal to minus 1 upon 2. So let us first prove the first part. That is from this given value of cos of beta minus gamma plus cos of gamma minus alpha plus cos of alpha minus beta is equal to minus 3 by 2. Let us prove that cos alpha plus cos beta plus cos gamma is equal to 0 and sin alpha plus sin beta plus sin gamma is equal to 0. Okay. So in order to prove this result, these two results, let us find out the value for this expression first. That is cos alpha plus cos beta plus cos gamma whole square plus sin alpha plus sin beta plus sin gamma whole square. Okay. So in order to prove this two required result, let us find out the value of cos alpha plus cos beta plus cos gamma whole square plus sin alpha plus sin beta plus sin gamma whole square. So let us find out its value first. So which is equal to, you know, a plus b plus c whole square, a square plus b square plus c square, you know that, plus 2ab plus 2bc plus 2ca, isn't it? So this is the formula that you can use here. A plus b plus c whole square is equal to, what is the formula? It is a square plus b square plus c square plus what? It is twice ab plus twice bc plus twice ca. This is the formula that you can use here. Okay. So here a is cos alpha, b is cos beta and c is cos gamma. Right. So what is the formula? What is a square? Cos square alpha plus cos square beta plus cos square gamma plus twice ab, that is 2 cos alpha cos beta plus twice bc, 2 cos beta cos gamma plus twice ca, 2 cos gamma cos alpha, 2 cos gamma cos alpha. So I think you have understood it. Okay. So now in the next step, you have to continue. So there is a continuation line here. So there is a continuous part here. So that is plus, again you have to use the same formula, sin alpha plus sin beta plus sin gamma whole square. So let us write it in the next step. Plus, actually this is the continuation line. Okay. So this is again in the form a plus b plus c whole square. Here a is sin alpha, b is sin beta, c is sin gamma. What is a square? This is sin square alpha plus what is b square? Sin square beta plus c square sin square gamma plus what is twice ab? 2 sin alpha sin beta plus 2 sin beta sin gamma plus what is 2ca? 2 sin gamma sin alpha, 2 sin gamma sin alpha. Is that clear? So let us simplify it first. So now let us simplify it. You know that cos square alpha plus sin square alpha is 1. Let us write 1 here plus. Similarly, what is cos square beta plus sin square beta? That is also 1. Plus cos square gamma plus sin square gamma, that is also 1. And from these two terms, 2 cos alpha cos beta plus 2 sin alpha sin beta, what is common here? Plus 2 is common here. So within bracket we have cos alpha cos beta plus sin alpha sin beta, right? Plus similarly from these two terms, what is common? 2 within bracket we have cos beta cos gamma plus sin beta sin gamma. So let us write this one in the next step. Okay. Plus again what is common here? 2 is common. Within bracket we have cos gamma cos alpha plus this is sin gamma sin alpha. So I think you have understood it. Okay. So 1 plus 1 plus 1 is 3 plus 2 into. So what is the formula that you can use here? Cos A cos B plus sin A sin B. That is your cos of A minus B. But here in this case, it is cos of alpha minus beta plus This is again 2 into cos A cos B plus sin A sin B. So what is the formula? Cos of A minus B, that is here beta minus gamma, plus 2 into, this is also cos A cos B plus sin A sin B. This is cos of A minus B, that is gamma minus alpha. So I think you have understood it. Okay. So now let us write 3 as it is, plus from the second term till last term, what is common there? 2 is common. So within second bracket we have cos of alpha minus beta plus cos of beta minus gamma plus cos of gamma minus alpha. So here second bracket is closed. So next you can put this value. You can put the value of cos of alpha minus beta plus cos of beta minus gamma plus cos of gamma minus alpha. It is given in the question, which is equal to minus 3 by 2. So which is equal to 3 plus 2 into the value for this expression within second bracket is minus 3 by 2. Okay. So here 2 gets cancels, which is equal to 3 minus 3, which is equal to 0. So this 0 is the value for this expression, isn't it? So let us write here, therefore cos alpha plus cos beta plus cos gamma whole square plus the next one is sin alpha plus sin beta plus sin gamma whole square is equal to 0. So now both are the sum of two squares, cos alpha plus cos beta plus cos gamma whole square. Whatever may be the value for cos alpha plus cos beta plus cos gamma, whether it is positive or negative, because of this whole square it will be always positive. Okay. Similarly, whatever may be the value for sin alpha plus sin beta plus sin gamma, whether it is positive or negative, because of this whole square it is always be a positive quantity. So positive quantity plus positive quantity is always positive quantity, which is never equal to 0. So this equation is possible only if these individual values of cos alpha, cos beta, cos gamma and sin alpha plus sin beta plus sin gamma is equal to 0. So this equation is possible if cos alpha plus cos beta plus cos gamma is equal to 0 and sin alpha plus sin beta plus sin gamma is equal to 0. Is that understood? So you have to write here, this equation is possible. This equation is possible, comma, if, what do we write? Cos alpha plus cos beta plus cos gamma is equal to 0 and what? And sin alpha plus sin beta plus sin gamma is equal to 0. So it is proved. So is that clear to all of you? So first part is done. I hope you have understood it. Now let us do the second part. Hence deduce that cos of beta minus gamma is equal to cos of gamma minus alpha is equal to cos of alpha minus beta is equal to minus half. So from this result, just now we have proved it. From this result we can prove that cos of beta minus gamma is equal to minus half, cos of gamma minus alpha is equal to minus half, cos of alpha minus beta is equal to minus half. So let us first prove cos of beta minus gamma is equal to minus half. Okay, cos of beta minus gamma is equal to minus half. Let us prove it. So now in this case we just prove that cos alpha plus cos beta plus cos gamma is equal to 0 and sin alpha plus sin beta plus sin gamma is equal to 0. Okay, now we are proving that cos of beta minus gamma is equal to minus half. So in this case cos alpha is taken to the right hand side. So what do we get? Cos beta plus cos gamma is equal to minus cos alpha. Okay. Similarly, from the second result, let us get the value for sine beta plus sine gamma is equal to minus sine alpha. Since we are proving cos of beta minus gamma is equal to minus half, so here alpha is not here. Okay, you have to prove cos of beta minus gamma is equal to minus half, and here alpha is not here. That's why this cos alpha is taken to the right hand side. So it is cos beta plus cos gamma is equal to minus cos alpha, and this is sine beta plus sine gamma is equal to minus sine alpha. So let us mark it number 1 and let us mark it number 2. So I think you have understood it. So let us square both the sides of 1 and 2. Squaring both the sides of 1 and 2, right? So let us square both the sides of 1 and 2 now. So it is cos beta plus cos gamma whole square is equal to, now this is minus cos alpha whole square, right? Similarly, you square both the sides of number 2, that is sine beta plus sine gamma whole square is equal to minus sine alpha whole square. Is that clear? So we have squared both the sides of number 2 also. Now what will you do with these two equations? What will you do with these two equations now? Now we will add them. So add these left hand sides. Therefore cos beta plus cos gamma whole square plus this is sine beta plus sine gamma whole square is equal to, so now what's about that minus cos alpha whole square? It is positive cos square alpha. This is plus cos square alpha plus what is minus sine alpha whole square? That is your positive sine square alpha. Is it clear now? So now in the next step, let us simplify it. Let us simplify it now. So let us simplify it. Let us simplify the left hand side. Now it is the formula a plus b whole square. What is a plus b whole square? You know that a square plus 2ab plus b whole square. So it is cos square beta plus 2 cos beta cos gamma plus cos square gamma. Okay? Then plus next one is also a plus b whole square, isn't it? That is sine beta plus sine gamma whole square. That is also a plus b whole square. So what do we write here? It is sine square beta plus twice ab 2 sine beta sine gamma plus sine square gamma, right? This is your left hand side, which is equal to, now on the right hand side there is cos square alpha plus sine square alpha, which is equal to 1. Or now let us simplify it further. What is this cos square beta plus sine square beta? That is also 1. And what is cos square gamma plus sine square gamma? That is also 1. Okay? And from these two terms, 2 cos beta cos gamma plus 2 sine beta sine gamma, what is common there? Plus 2 is common out here. So within bracket we have cos beta cos gamma plus this is sine beta sine gamma, which is equal to 1. Is that clear to all of you? From both the sides you can cancel this 1, or this is 1 plus 2 into what is the formula? Cos of beta minus gamma. Cos A cos B plus sin A sin B. What is the formula? Cos of A minus B. That is cos of beta minus gamma, which is equal to, this is 0. So 1 is taken to the right hand side. So it is 2 cos of beta minus gamma is equal to minus 1, or what is the value for cos of beta minus gamma is equal to, this is minus half. So it is proved. Okay. Now we have proved this cos of beta minus gamma is equal to minus half. Now similarly you can prove that cos of gamma minus alpha is equal to minus half, cos of alpha minus beta is equal to minus half. So how can you prove this cos of gamma minus alpha is equal to minus half? You have to take this cos beta to the right hand side and sin beta to the right hand side, and similarly you can use this method. Similarly you can use this method in order to prove that cos of gamma minus alpha is equal to minus half. Similarly, how can you prove that cos of alpha minus beta is equal to minus half? How can you prove that cos of alpha minus beta is equal to minus half? Similarly, this cos gamma is taken to the right hand side, and this sin gamma is taken to the right hand side, and proceeding in this manner, we can prove that cos of alpha minus beta is equal to minus 1 upon 2. So in this case, we can write, similarly it can be proved that cos of gamma minus alpha is equal to cos of alpha minus beta is equal to minus half. So we have shown first one, that is, we have proved that cos of beta minus gamma is equal to minus half. Then for the next two, we can write down that similarly it can be proved that cos of gamma minus alpha is equal to cos of alpha minus beta is equal to minus half. So let us write here, similarly it can be proved that cos of gamma minus alpha is equal to cos of alpha minus beta is equal to minus 1 upon 2. So it is proved. So I think you have understood it. So this is quite complicated one, but it's very, very important. So you can mark it as very, very important problem. Okay, so you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 5 from page number 140. So let's do this question number 5. So here alpha not equal to beta is given. Alpha is not equal to beta. And also it is given that a tan alpha plus b tan beta is equal to a plus b into tan of alpha plus beta by 2. You have to prove that cos alpha by cos beta is equal to a upon b. So let us prove this cos alpha by cos beta is equal to a by b from given. Okay. So let us write down given here. Here given is a tan alpha plus b tan beta is equal to, it is a plus b into tan of alpha plus beta by 2. Okay, so now let us simplify it further. Since you have to prove cos alpha by cos beta is equal to a by b, let us simplify it and keep the terms containing a on the left hand side and the terms containing b on the right hand side. Okay, so now let us simplify it first. A tan alpha plus b tan beta is equal to, let us multiply it, a into tan of, this is your alpha plus beta by 2 plus b tan of, within bracket, alpha plus beta by 2. So I think you have understood it. Now since you have to prove in terms of a by b, that is cos alpha by cos beta is equal to a by b, let us keep the terms containing a on the left hand side and b on the right hand side. Okay, so let us write b tan beta first here, then minus plus b tan into plus b tan of alpha plus beta by 2, it is taken to the left hand side. So it is minus b tan of, this is alpha plus beta by 2, which is equal to a tan of alpha plus beta by 2, then minus a tan alpha, that is a tan alpha is taken to the right hand side. So it is minus a tan alpha. So is it understood now? So next, what is common here? B is common here. So within second bracket we have, this is tan beta minus tan of, this is alpha plus beta by 2, second bracket is closed, is equal to, what is common here? A. Within second bracket, this is tan of alpha plus beta by 2 minus, this is your tan alpha, right? So now let us write down the trigonometrical ratios or trigonometrical functions on left hand side, and that A and B on the right hand side. Okay, so now this is tan beta minus tan of alpha plus beta by 2, and now let us take this tan of alpha plus beta by 2 minus tan alpha to the left hand side. So it goes to the denominator, tan of alpha plus beta by 2 minus tan alpha, which is equal to, this is A by B. Now B is taken to the right hand side, so you should write it in the denominator. Okay, now we have got this right hand side. Right hand side is okay, that is A by B. Now you have to simplify this left hand side. Okay, so let us simplify this left hand side now. Now in the numerator, what is tan beta? Your tan beta is sin beta by cos beta minus, what is tan here? Sin of alpha plus beta by 2 divided by cos of alpha plus beta by 2. That is sin by cos. Okay, similarly, what is tan of alpha plus beta by 2 again? Sin of alpha plus beta by 2 divided by, this is cos of alpha plus beta by 2, right? Then minus, what is tan alpha? It is sin alpha by cos alpha. Minus, this is sin alpha by cos alpha. Is that clear? So which is equal to A by B? Which is equal to A by B. Or now what's the LCM? What's the LCM in the numerator? In the numerator, cos beta into cos of alpha plus cos of, this is alpha plus beta by 2 is the LCM. Okay, so cos beta gets cancelled, so it is cos of alpha plus beta by 2. So this is sin beta into cos of alpha plus beta by 2, right? Then minus cos beta into sin of, this is alpha plus beta by 2. Now you know how to simplify it. Take the LCM and simplify the numerator. Now in the denominator, what's the LCM? What's the LCM in the denominator? It is cos of alpha plus beta by 2 into cos alpha, isn't it? Now this LCM is divided by cos of alpha plus beta by 2. So it is cos alpha only. So it is multiplied by sin alpha plus beta by 2. So that is sin of alpha plus beta by 2 into cos alpha minus, now again this cos alpha. This LCM is divided by cos alpha gets cancelled. You will have cos of alpha plus beta by 2. So this is cos of alpha plus beta by 2 into sin alpha. Into sin alpha, which is equal to, this is A by B. So I think you have understood it. So you can cancel here this cos of alpha plus beta by 2, and this cos of alpha plus beta by 2 will be cancelled. Now let us simplify it again. Or now in the numerator, what is the formula? Sin A cos B minus cos A sin B. The formula is sin of A here is beta minus alpha plus beta by 2, right? So divided by, so it is cos beta. It is cos beta into, now when this denominator goes up in the numerator, it becomes upside down. So cos alpha goes up in the numerator. So this is cos alpha divided by. Now in the denominator, what's the formula? Again it is sine A. Alpha plus beta by 2 is A and alpha is B. Sine A cos B minus cos A sine B. So what is the formula here? This is sine of A minus B. Alpha plus beta by 2. That is A minus what is B? Minus alpha, which is equal to, this is A upon B. Is that clear now? So let us simplify it again. So let us simplify it. So let us simplify it again now. So what do we get in the next step? Let us simplify. Sine of within bracket LCM is 2. Sine of within bracket LCM is 2. So 2 into beta, 2 beta minus alpha minus into plus minus beta. Right? Then into cos alpha. This whole divided by, in the denominator, it is cos beta into sine of, what's the LCM here again? This is 2, right? 2 is the LCM. So in the numerator we have, this is alpha plus beta and then minus 2 alpha, right? So which is equal to, on the right hand side, there is A upon B. So let us simplify it now. Again, this is sine of within bracket 2 beta minus beta, beta minus alpha by 2 into cos alpha. Next, cos beta into sine of, here also let us write beta first. Then what is alpha minus 2 alpha? Minus alpha divided by 2, which is equal to, this is A upon B. Okay, so here you can cancel this. Sine of beta minus alpha by 2 will be cancelled from both numerator as well as denominator. So, or this is cos alpha by cos beta is equal to, this is A upon B. So we have proved it. Okay, so it is proved. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 6. The question is, if sine theta is equal to k into sine of theta plus phi, prove that tan of within bracket theta plus phi is equal to sine phi divided by cos phi minus k. So this question is very important. You may get this question in promotion examination also. Okay. So now what is given here? Sine theta is equal to k sine of theta plus phi is given. You have to prove that tan of theta plus phi is equal to sine phi divided by cos phi minus k. That is LHS is equal to RHS. So what is left hand side here? It is tan of theta plus phi. So how will you prove it? You know tan of theta plus phi is tan of A plus B form. What is the formula? Tan theta plus tan phi divided by 1 minus tan theta tan phi. So you have to get the value for tan theta from given. From given, you have to get the value for tan theta. The value for tan theta is not given directly out here. You have to get the value for tan theta from given. And what will you do with it, with this tan phi? So for tan phi, you have to write sine phi divided by cos phi. Is that understood? Now let us prove it now. So let us write down given first. What is given here? It is sine theta is equal to k sine of, this is theta plus phi. So let us simplify it and get the value for tan theta from here. Okay, sine theta is equal to k. What is sine of A plus B here? This is sine theta cos phi plus cos theta sine phi. Is that clear? Next, let us simplify it. Or this is sine theta is equal to multiply by k here. So what do we get? K sine theta cos phi plus k cos theta sine phi. K cos theta sine phi. Okay. So now since we are getting the value for tan theta from here, let us keep the terms containing sine theta on the left hand side. Let us write down the terms containing sine theta on the left hand side. Okay. Or this is sine theta. Let us take this k sine theta cos phi to the left hand side. It becomes minus k sine theta cos phi. And on the right hand side we have k cos theta sine phi. It is k cos theta sine phi. Okay. So what is common out here? So sine theta is common here, isn't it? So here sine theta is common. So within bracket 1 minus k cos phi, which is equal to k cos theta sine phi. So I think you have understood it. Okay. So next, in the next step, what will you do? Now in this case, let us take this cos theta to the left hand side and 1 minus k cos phi on the right hand side, so that we can get the value for tan theta in terms of phi. So, or now this is sine theta divided by cos theta, isn't it? This cos theta is taken to the left hand side. Okay. So you should write it in the denominator. So now k sine phi divided by, again you can take 1 minus k cos phi to the right hand side. So you should write it in the denominator on the right hand side. So it is 1 minus k cos phi. Is that clear? What is sine theta by cos theta? That is your tan theta, which is equal to k sine phi divided by 1 minus k cos phi. So we have got the value for tan theta. Is it clear now? So now we can prove that this LHS is equal to RHS. Now let us prove left hand side is equal to right hand side. So we have got the value for tan theta here. Okay. So LHS is equal to, it is tan of theta plus phi. So what is this? Tan of A plus B. Here A is theta and B is phi. So this is your tan of A plus B. So what is the formula? Tan theta plus tan phi divided by 1 minus tan theta tan phi. Is that clear? So now let us put the value for tan theta here. So from given, what is the value for tan theta? It is k sine phi divided by 1 minus k cos phi. Let us write it there. So what is tan theta here? It is k sine phi divided by 1 minus k cos phi, 1 minus k cos phi, right? So this is the value for tan theta. And what will you write for tan phi? It is sine phi divided by cos phi. Is that clear? Similarly in the denominator, 1 minus, what is tan theta out here? Same value, k sine phi divided by 1 minus k cos phi into, what is tan phi? It is sine phi divided by cos phi. So tan theta here is k sine phi upon 1 minus k cos phi. And what's about that tan phi? It is sine phi by cos phi. Okay. Now let us simplify it. Let us take the LCM in both the numerator as well as in the denominator. So what's the LCM in the numerator? It is 1 minus k cos phi into cos phi. Okay. Now this LCM is divided by 1 minus k cos phi. So 1 minus k cos phi, 1 minus k cos phi will be cancelled. You will have cos phi. So cos phi is multiplied by k sin phi. So what do we get? K sin phi cos phi. Right? Plus sign is there. Now this LCM is again divided by cos phi. Cos phi will be cancelled. So 1 minus k cos phi should be multiplied by sin phi. What do we get? Sin phi into 1. This is your sin phi minus k sin phi cos phi. That is this sin phi is multiplied by 1 minus k cos phi. So we got this result. So we have simplified the numerator. Similarly, you can simplify the denominator. So what's the LCM in the denominator? 1 minus k cos phi into cos phi. This is the LCM. Okay. Now this one should be multiplied by this LCM. So it is 1 into cos phi. It is cos phi minus k cos square phi, right? That is k cos phi into cos phi is k cos square phi. Then minus k into, again you can multiply them, sin phi into sin phi is, this is your sin square phi. Clear? So now denominator is also simplified. Now you can cancel this LCM. This LCM will be cancelled. Okay. Now in the numerator you can cancel k sin phi cos phi minus k sin phi will be cancelled. So which is equal to, now in the numerator what is there? In the numerator there is sin phi. There is sin phi divided by, in the denominator you write cos phi first, then minus k cos square phi minus k sin square phi. That is common. K is common. So minus k is taken common out here, and within bracket what do we get? Cos square phi plus sin square phi. So it is cos square phi plus sin square phi. So minus k is taken common out here, and within bracket we have cos square phi plus sin square phi. So which is equal to sin phi divided by cos phi minus k into, what is cos square phi plus sin square phi? That is your 1, which is equal to, this is sin phi divided by cos phi minus k. So it is proved. So I think you have understood it. So we have proved that this left hand side is equal to sin phi divided by cos phi minus k. So it is proved. So I think you have understood it. So this question is very, very important. You can mark this as very, very important question. So you can copy it. I hope you have understood it. So today also we did some problems, that is 4 or 5 or it may be 6 problems. So you revise all the problems that we did today, and also you have to revise all the problems that we did in this chapter, trigonometrical ratios of compound angles. And in the next online class we will do more problems on this chapter. So this much is for today.